I'm streaming. Yeah. Yes. Welcome to the channel. Date now. The time now is 6:05. The 6:05. This is the 20th of February 2026. So let's continue. So I'm gonna draw something on the board now. It's not formulated. Draw something. So this is basically an armory. It's an armory building. So basically, it's just a dressing some armor. So you have an armory, which gives you armor and stuff like that. But it's for CB compliance armory. So you got an armory system for SA, if echo, self for zero, if echo. This armory system. So you're gonna have dressing room. So I'm gonna draw it properly. But I'm gonna draw it like I know it. You know how I know it instead. I'm gonna start with it. So I'm gonna do some drawing on the board. What was to draw it, you know? So we got armory here. So you go armory here. So we're going to do an armory here. So you're gonna have the dressing room. So exit spelled if echo, 0 if echo. Now the exit dressing armory is armory space and time. It wasn't gonna replace more of radio waves, but it's an armory that physically dresses up and the mime system. So the mime system, I'm gonna introduce you to the question. If you can break something, if you can build something, this is the enzyme model. If you can build something, you can break it. If you can do something, you can break it. If you can do something, you can rebuild it, you can break it. If you can bind something, bricks you can bind it. If you can create something, you can destroy it. Destroy it. If you can build, break, and bind. If you can create something, you can destroy. If you can destroy something, you can create. If you can, if you can repair something, you can renew it. You can make it a new one. You can make a new one of it. Renew it. So the thing is, the only factor here is space and time. Space and time. Space and time. Space plus time. So I'm gonna give you one eventually the model in the nice way possible. I'm gonna give you the model in the easiest way to follow. But it's really just a dressing room that's for armor. It's a dressing room for armor. So basically, I'm trying to make armor that just takes like 30 seconds to put on, 30 seconds to wear. It's basically built around the person. So this goes to my next point. Next point. Why do this? So armor is how to normally clunky, but I'm going back 300 years in my life and like barefoot to show the war armor. So you normally have a wicker, which is like a whip, a wicker, which is like a wicker, and a shield for the shield. But this is an armory, so the shield. But the wicker shield are very good. So how long do you think to take a wicker and a shield? That will become armor. But as long as you keep evolving the wicker and the shield, at one point in time and space, you need to wear them. If you do it wrong. But the armor has to sequence in this kind of frame of space time. Space and time to put an arm for you. That's why you put it in the first place. You can't just take the wicker. The wicker is like that you hold a wicker, you just whip with the whip. But it has many whips. We wrap people's hands and pulled up but it wraps you, the shield can bash you, and you can have a shield in your back. So you can have a shield on your back, a wicker in one hand, and a sword, a dagger. You can have a knife, you can have a dagger, and you can have a sword, but the sword is extensive. You have this is evil armor. So I'm trying to develop the system for 300 years plus. Because of 15, let's say 25 to 20 years. But this armor room, this way the things, build break, this is called a perceptive model of the armor. So perceptive model. So I'm going to give you the perceptive model using radiography right now. So radiography is can you have radio internet if you don't know. Radio internet, just internet based on radio. So like can have because radio waves contain all the properties of the electrical demonstrators. The control demonstrates illustrate all the properties. Red, orange, red, orange, visible light, radio, red money is only visible under ultraviolet glasses. Radio waves, microwaves, infrared, visible light, X-ray, and gamma rays. I'm saying to you guys, it's not a trick question. Can you, or the man guys, if you're able, what's the word? Cha cha cha, cha 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 cha, cha cha cha, cha 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 cha. But it's basically system model. So the works. Don't come here, Lucas. Sorry, it's putting on. Sorry about that, man. So you have a system of armor. So the armor is basically give you armor. So in time. So this is what you're fighting at all. Get the armor, you go. Basically, it's not traditional. It's not traditional suit. It's basically whatever you have, you wear it, you put it on time. It's like the problem I really see is that people should just get armor and just go to war, waste it, But armor is protection. So I'm gonna give you a screen. So I'll start with the perceptive model. So I'll put it here, perceptive model of the system of perceptive threat detection. Perceptive threat detection, which was defined formally on paper and so you get a path perceptive threat model, you get a half model one, which is the perceptive radio threat model. So this was it. So I'm gonna formulate this today, because I do probably, but you just want to get an armor, you just go in there, you get your armor, you go. Basically the mine system. So you get the system. The mine system, mining. So why is it so? Also the mine system. The mine system is basically a mine. So it doesn't matter how the job, if it's transformed. Basically, in my frame of reference, it doesn't matter how far you are, everything that you're seeing in front of you is not transparent, but everything that's very far away is transparent. It's so far away, it's transparent. So the mind system are very, very important. You see what I do because if I'm like this, I'm standing to put my arm on, or my hand has legs. So if I'm like this, and oh my days, if I'm in a T pose, and the T pose is here, and the system put on my arm up and one finger up, that's the point from left to right, just to perceive whether I'm, what's the perceptive mind model, yeah. Just to perceive whether I am standing right or facing left, because we have a natural way we can put on our clothes. You don't know that, we have a natural way to put on our clothes, whether you start from left to right. But it's supposed to perceive the way, it's non-negotiable. So you can start from perceptive mind model. Basically, you can start by perceiving one way. So if I put on this, I want to put on this, I'm going to do that. Yeah, I do. Say I want them to use top off, for example. Let me just show you stuff off. No, let me just also off camera, of course. 1 second, guys. So I'm coming back now. So I'm here again. I'm still going to top off. Say this is just a shackle. Look up, use people. But this table to map it to me. This mesh is say I have a robot to pull on me. Robot's watching me to pull out this mesh. The top will be facing me, but I want to just put this top up. I used to put it on. So instead of me putting it on, someone has to put it on for me to make it faster. You may think of it's counterintuitive, but I cannot see my full body. So I can have mistakes, by this kind of model. So I cannot see my full body just facing me. So the perceptive model obviously must map this close to me. My hand's not lifted. Stretch. Sorry, my God. So this was the map to my torso and my body track. So the armor will be put on, but that means there has to gaps or some kind of breathing holes, so it has to be elastic, and it has to be natural. If someone put it on for me, it's faster because I can see my full body. If I just do a spin, spin. If I don't want to go to the ankle, so I must work around my joints. The arm must work on my joints too. It's work on my joints. Like by working on my joints, it means like I have a joint here, my elbow. But when I put on my clothes, I can be stuck in an elbow position. And most it comes from the safety net of it. But the mind system is very important to start. I can't earlier, but apart from this top I'm showing you guys, it has to be built around my height, my weight, my body, but it has to be elastic. So it has to be elastic. So you have to have a shared property. All this and this will be an armor system, but I'm thinking about this is my own dressing. So normally, so if I stand, so for me, the only problem is I'm standing sleeping. If I start sleeping, I just start sleeping. No, I just stand up sleeping. Like, I miss the kind of chicken. I mean, it's sticking jargon right now. But if you're going to war or something, this is why I made it. So you can dress quickly, get to war, get to the fight, and do it. That's what I made it. Because standing up sleeping is not counterintuitive. But your brain can do that. Your brain can do that. Your brain can do that. You just need to understand. You just need to understand that you have to get used to it. You get used to it. So your brain can literally put you in a state of not walking and sleeping. That's what you can do. We can be and can be lying down and sleeping because your brain is a state. It's a state. It's a lucid state, and that's what makes you sleep when you're standing. Sleepwalkers can really stand. You need to stand and stay still. That's what it is. Stand and still. And you don't need medication for that. You just need you just need to understand that you are in a state of standing and sleeping. Like, basically, it's just a chemical condition in your brain that makes you sleep when you stand. You may feel this will come on, but standing sleeping is just quite common. It's just that so it's just not coming, guys. It's just that it's not coming. It's not common thing. I'm saying that it's a weird thing to have to even understand the science behind it to understand why it works the way it does. So standing and sleeping is not a hard thing to achieve. You just understand that you're still awake. You're just ready for the facts. You're just ready to sleep. So I'm trying to have me stand and sleep and in a pod. So I will be the pod will protect me. Because if I'm standing, I'm ready to engage with the enemy already. I'm ready to fully engage with the enemy. When I wake up, but if I'm sleeping, so I can just attack my neck, attack my back, attack my my biology stuff. Because I am not. I can only have to just open my eyes, perceive the threats, and deal with the threats. That's what I have to do. So it's basically gonna be the pod. So the pod will be where you're gonna be in. So if somebody was to put on a shirt, I can take a shirt and just put it over my head. I'll put it on my head like this. I'm standing straight, of course, and put one hand here, and put one hand here. But there's another way. The computer has to try to do this for me. So, one way the computer can do it is basically by folding the arms over. So basically by projecting. So if I have, for example, if I put my hands here forward, the computer can put it through my hands, but do my hands first, and then do my neck for the armor, they do my body. But it's basically a perceptive mode for armor. So this is basically watching you from an angle, from an angular momentum, from an angle. Can seriously, if you know if I'm saying this, perceptive is used for calibration. So second thing, perceptive is used for calibration. So for example, that's what I'm going to next. So I'm going to say the problem. This is the problem. So next one was here's the question. Your relation with skull. So your pods, the sleeping pods are basically armor bound. So this is more you sleep in a pod. But I'm giving example, giving weird example, very example. You never see this example, but the goal is to have it upright, because you are, of 45 degrees, 45 degrees, for every 45 degrees, because if you try, you can understand what I mean. Sleep 45 degrees, you can sleep, you can sleep 90 degrees, you can sleep 45, you can sleep 90 degrees. Thank you. So you can sleep upright. You can sleep. So I prefer 85 degrees, not 90, but you can sleep upright. You can sleep upright in the pod. So that is introduced to the kind of part of building. So it's basically for threat modeling. So basically, let me do the proof now for the other thing. So the proof here. So what I'm doing. So this time I put something. So I have a paper here I made before, but this is basically the mind framework, the mind. Okay, so I'm trying to model transparency as a quantifiable eigenvector. Transparency. So you get the measurement of nothing. To get eigenvalues. So eigenvalues are measures of nothing, of nothingness, something, not something, or nothing of something, or something. Let's say example, you have the color uh, blue. Blue. You have you can take blue, dip it in a kind of dip it in water, some of the paper, blue paper, dip it in water, dip it in some solitude, like a water, and you get translucent blue. So basically, the paper is basically use A4 paper. and it's like painted blue. I dip it in some kind of chemical solution, also called solitude. You take it out, it becomes translucent and blue. So you get a blue, just the color blue, same color. But you can have a blue hue. So you can have a blue hue by shining a light through it. If it's fluorescent, so if the paper is fluorescent, you get a hue that is blue. Hue blue. So I'm giving an example now. So you're gonna have a system for blue hue saturation. Saturation equals time. So if I have the paper and I put it in water and it's blue and it's fluorescent, that means it glows like neon. It's neon blue. Neon blue. You put it in water, put it in saturation, and you have saturation. In time, it's saturated. Over time, you can have more saturated, thinner tinta. Like the more time you put in, the more you dip it into, the more you hold it in underwater, under the solitude, under the thing, making it making it take away the blue color. You're gonna have in time. See, you have it for 60 seconds. Let's say you have it for 10 seconds. 10 seconds. You'll become fully transparent. Fully transparent to 0 to 10 seconds. Fully transparent. So if you hold for 5 seconds, it's half transparent, half transparent, so half translucent. So it's, basically, lucidity translucency is a half between the ideal value of the whole blue. So it rules the word saturation value, lightness or value. So the lightness will be HSB. Huge to the lightness. So the lightness will be the quantifier for the system. So lightness will be how HSR, basically the HSL model of the color system. So you're gonna have the HSL model. So the HSL model works across all color systems. You're gonna have a huge saturation and lightness, and the lightness is basically determined by yeah, I don't have this spoon. I'm streaming. I'm talking. Okay, bye. No, you can. You can. Sorry about HSL. So you're gonna have HSLA, HSL lightness, and alpha. Alpha channel basically 0 to 1, 0 to 1. So if you have how's lightness measured? How lightness is measured by the lightness of the color. So lightness will be how much intensity of basically this would be the contrast. Fully light to first if you say 0 to 10, fully light to 1 to 0, fully light to B. So if you want half a light, you want to just keep it in a vacuum or something. I don't know how I did it, but there's a lightness quantifier here. That can I think it's to shine a torch through it. You have to go yeah, you have to take the room and so basically, this is what's in the use situation. And the lightness is the color blue is red FF or 00FF 00. So red, green, blue. So 255. So 255. So 0 FF. So you can have lightness. The lightness will ultimately will be. I think it's a multiplier. So you have to multiply by the color to have a lightness. So the goal is to have a quantifier for the system. So you're gonna have a system. Right. So so you get the mime theory. So I think the lightness will be the what make it yeah. So basically the light would be yes, lightness will be invisibility factor. Visibility. So lightness is not a color. It's basically what is invisible in the medium. And it's this will determine whether it's transparent or opaque. So the lightness is really what I talk about. Trying to think about stuff. So lightness is transparent or opaque. If it's warm, you can see it. I can observe it. If it's 0, you can visit it. So it is the invisible cloaking device for invisibility. So apart from the cloaking, I'm going to talk about the mind. So the perception of the system is: can I see this color in this space at this time? Or because the armor is really defended of the system. This is what the armor is, or what the armory contains. You want to distribute or not to take a measurement of the security because you're getting dressed. You are literally just getting dressed. So the armory was there. So HSL, so hue, take a paper, take away the material you're doing, any material, dip it in a solid tube, which means like some kind of a liquid property that will give it to separate the tint and tone. So a solid tube, a solid tube is water, is liquid. A solid tube is solid. So tooth and tooth are solid. So you have the tint tone. So you should separate the tint and tone that will make it visible at an angular momentum and an angle. So basically, how it's perceived is based on the angular momentum of the system. So you can have something perceived one way or the other. So you're gonna have a model. That's the model I'm giving you guys for the visibility of a cooking system. But it is not. You can this can be repeatable. So I'm going to tell this video as experimental invisibility armory. Uh, invisible system. So invisible experimental armor. So so the tint and tone what you're trying to control over HSL, hue, session, and lightness. Trying to calculate control of these factors for the medium, for the hydrocarbons you're operating, which is like the polymers you're using, hydrocarbons, hydrogen and carbon. Basically, we're carbon-based life forms, so you have carbon energy. So I'm saying to you, H2O. But we're carbon-based life forms because we breathe in the air and we breathe in oxygen and breathe out carbon dioxide. So we need the carbon flows through us. But we have hydrocarbons. We are hydrocarbons as well. So hydrocarbons could we have hydrogen. We breathe in hydrogen. Hydrocarbon is basically a polymer framework for biological stability of human systems. So you can have something like a tattoo that's how God work tattoo. I'll come with that later. No, so listen, the MIME project. So the MIME, so the perception of the tip and tone is done. So the MIME is it's going so the MIME is basically imagine someone that's a mime. He mimes his whole life. He doesn't want to speak to you. He doesn't enjoy by voice. He doesn't turn what he also does by miming. He doesn't so his language he uses sign language. So these gestures are called mimes. Because they mime the reality, they show reality that we don't observe. But those things are real to them. In their frame of reference, they're real. That's real. So we are trying to create an influence coding to ensure that things we can't be seen, like a mask, like a visible cloaking device. So if I have something and I mask it, I am let me see this close. You can have say you have five. Let's say my number is 07 488 229054. Seven is mapped to seven has an open loop. Open loop. Seven has an open loop. Seven can replace a four. Zero has a closed loop, so zero can replace with a nine. So get 07 09. Four. Four has an open loop. Four can replace with a two. Eight has a closed loop. Eight has a closed loop. Eight can replace with a zero. Eight is replaced with a zero. Two has no open loop. Two can replace with a closed loop, which is eight. Eight. Oh no, open loop two. So 7 0 with a 9, 0 and a 9, 7 and a 4, 1 2 3 4 5 6 7 8 9. So 7 maps to a 4, 7 maps to a 4, 0 maps to a 9, 4 maps to a 4 again, maps to a 2, 8 maps to a 0. Oh, 8 maps to something else. 8 maps to, let's say 8 maps to two zeros. Two zeros. Two zeros goes, 8 maps to close to 6. 8 maps to 6. 8 maps to 6. So my number will be 0. When I say 0, I'm given a 9. When I say 4, I'm given a 2. When I say 7, I'm given a 4. When I say 4, when I say an 8, I'm mapping that to 6. 8, 6, 2, 2, 2. Yeah, 2 is a closed loop. So 2 should map to an 8. 8. 2 to 9. 9 should map to 0. The 0 maps back to a 9. A 5 maps to 4. A 5 maps to 3. A 5 doesn't have a closed loop. Okay. So 3, 5, 4. Open to close. A 5 maps to 2 zeros. And the 1, 4 maps back to 4 maps to a 4 maps to 2. So this is what I call the closed loop problem. So my telephone number is 07 488 22 9054. It's basically a category problem. Basically, my number is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it's a masculine problem. It's literally just my number. It contains all the context of, why is my number unique? This is just a subset. This is a subset. Simply, this number is a way to say 07 488 22 9054. It's a way to say 1, 2, 3, 4, 5, 6, 7, 8. It's just another way to say it, guys. But everyone has that number. So this is my number. It's unique to me. So this is just my address. So this phone number is a literal address for something I need. My phone number. So, but this is a closed loop problem. So if I have an open loop, I replace a closed loop. So these are just numbers. So my number is really, if this is my number that we share, so if we share 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the alpha we share, and my phone number is 07488. So if the numbers 1 to 9, 0 to 9 are used, and my phone number is 07 488 22 9054. Then I have an address. So my address, my closed loop, I just work with. So if I see an open number, open hope, I put a 9. I make it a closed loop. So 0 is a closed loop. No, 0 is closed. 9 is open. Oh, so I made this wrong. So this should be wrong. So 0, 2, 2, 2, 8, 2, 8. Okay, let me just give you this system. So this is wrong model, but let me try to do it again. So basically, you're going to have so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll get 0 to 9. I will have so if I have a 0, my 0 can be 0. I pick 0. If I have a 0, so 0 7. If I have a 7, I have an open loop. So O equals, so 7 is a 0. 7. So my 7 maps to 0. If I have a 7, 4. My 4 maps to, it's an open loop. So basically, the open loop is just like if I have an open 4 doesn't have an open loop. So the 4 is the number you can write. It's the same you can write without indicting itself. So same you can write. So 4 maps to an open loop, and that will be probe. So if 7 is 0, 4 will be closed. So close will be 8, 4, 8. So my number so far from 07 is 0. From 07 is 7. From 0 from 7. So if everything was from 7, 7, 4, 7, 7 becomes 0. 4 becomes 8. 8. So my number is now 0, 8. 0, 8. Now my 8 is a closed loop. So that will be an open loop. So if I solve it, so you can only go one way loop. So the why this matters is because of coloring. So if my number is 08, 08 will be let's say just take 08. This is 08. So it's 474. My first number is 08. So if you think of a radio system have a way to go. They propagate in one way. because basically the one-way propagation is like you start from radio waves, you get radio waves, you get microwaves, you get visible like radio waves, microwaves, red money is infrared, and you get visible light, ultraviolet and X-ray, gamma rays. I'm busy, get you. I haven't, no, thank you, sorry. So the fact of the matter is, this closure, you make it the numbers intuition, but it basically maps because it's closed in that sense of so. The goal I'm saying is radio waves, microwaves do the same thing because they come a stream of they start from radio waves, but we don't start to measure radio waves when we are using when we're using X-rays or gamma rays or radio waves. So we don't see that. We just use the system. So there's some kind of disjoint property to the share. So let's say so radio waves, microwaves are there. So if I'm heating a food, I'm not in a channel. I'm not in a radio channel. I'm not. I'm using. If I'm using I'm not. If I am using a television that can see showing me lights and pictures, moving pictures. If I'm watching a movie on television, I'm not using the X-ray. I'm not scanning my legs. There's no X-ray for there. There's nothing. There's no gamma rays coming from that system of the X-ray. There's no gamma rays. It's not gonna hurt my eyes too much to make me give me cancer. They don't say we get TV cancer. So this was very important. No share cancer in common region. So don't say that one. So basically the same problem is the closed room. So the closed room is very important to understand because the rooms are color coded. So you have red. So the red. So you have an indicator. So the indicator is another pointer. So you have an indicator. So you have radio waves, microwave, infrared, visible light, X-ray, gamma rays. And you have red, orange, we should have yolk, yellow, red, yellow, blue, green, we should have yolk, red, orange, yellow, blue, green, indigo, violet. Now the problem is you cannot measure. You can also reorganize the indexing. So this is an indexer. What I call this tracker. This is an indexer system. So but it's a heterogeneous homogeneous indexer. So basically it can reorganize itself. So it's not like one. It's not like index I2 I equals 9 I equals it's not an indexer. Basically it's an alphanumeric indexing system. So it's like so you can if you have 0 to A2. So if you have A2 A B C D E F G H I J A B C D E F G H I G. So A to F 0 to 9. You have a hexadecimal alphanumeric custom, but the character is hexadecimal. So I'm mapping, but you can start from 1. Not just start, you can start from 1 to count. You can start from 1, but you're not doing moderation. You're doing reshuffling. Basically, you're gonna do repointing. The pointer is try the 3 pointers to the system. For example, you're gonna have a way system with system. So the problem is that the digital property of this joint, because you can start counting, you can start making a system move from 1. Computer just start at 0 because it was common sense for us. But it's not efficient for the computer. It's common sense for us. So red, orange, yellow, or blue. Which one of you gave green, then blue, indigo, then violet? It's just a way of saying that that's what we agreed on. That's the consensus. That's consensus we have. Consent and consensus we have. So the red, orange, yellow, green, blue, indigo, violet is just a code. We can start from indigo. Now my problem is very important to understand because if I'm translucent, I can see through. If I'm transparent, I can't be seen through. But if I'm opaque, I can't be seen. So it's basically an armory, kind of armor that that can be cannot be seen visibly. But what's the video about? Basically, this video was about the kind of philosophy of armors and wearing clothes and stuff like that. But it's a dress room, so your armor is invisible. Your armor is invisible. What you're wearing is invisible. You're not naked. You're not naked in the kind of spectrum of the measurement. But the armory is gonna be the armor itself. What you're gonna wear in time. You're wearing this in time to like it may sound counterintuitive. I'm going to get into war. I'm just like theorizing. But the mime just mimes right. So when someone sees you do some action, you think you're miming. But what are you miming? So if I'm drinking a cup, if I have this thing, this glass of thing, but it's transparent. This is transparent, but this orange juice is inside. Yeah, basically today is putting oranges inside from the last video. So last video I didn't put the oranges, so here's what looking for that prop. So now the oranges is there in the inside of this jug. Now everything is transparent. Now if this orange juice is in the jug, like literally, what's in the jug, orange juice, I can see it, yes, from the outside inside. But the glass must have really cannot see. So you can share people you want to see of your reality, so they can see nothing of the way it's done. So it doesn't matter what you can see. You can show people nothing of your reality by seeing through you. So it's kind of warped reality. So the quantum physics explanation of this is that the mime enters a room, he has a job, but the mime is miming stuff. So, but it's also basically it's all real to the mime. Everything he does. The red room, he has a red room. The red room. So he has the red room. He has the room. That's the red room. So the red room is build, or red room is brick and break stuff. The green room is build stuff. So that maybe which of red, green, blue. Build buying in between blue. There's a computer code. There's another color to red blue. So the build and break. So the red room is build. The red room is break. The repair. Renew. What be renew? So the color of a new something is the white room. Something that's new goes in the white room. Think of it as assembly. You put it in white because it's new, and you repair something. It goes to the gray room. The gray room. So it's white and gray. Let's say it's pale room, the white room, and the gray room. So repair something, it goes to the gray room. So what you can observe is this kind of color coding for the system. And if you want to rebuild, renew, repair, break, or bind, renew, repair, build, break, create. If you want to create something. Oh, I made a mistake. Create something. Oh no. So let's say create something is the white room. Destroy something is the black. Destroy something is the gray room. It's the black room, and new something is the gray room, and renew something is the gray room. No, repair something is the gray room from spectrum to gray, and repair something is all the other colors like the tint and tone, gray room. So red, green, gray room is renew or repair. Renew. So basically, repair is gray room, and renew is make it again. So basically, repair and renew a B1 room. Good, but it's a system, so you have to be so if any flash you go kind of system. See, don't follow system, but follow it formally to show you it's practical. So red room destroy something. Break something, red room break something or destroy it, green room build it. So imagine someone else. Imagine you're facing some kind of side. You have a red a wave, a radio wave, pointing so radio wave. You're walking towards the radio wave. This is a see. So something you're walking towards something that's taking a measurement of radio wave. So you are here. I'm here. Let me join the board. Listen. So basically, I'm here. And I'm looking towards the radio wave. So the radio spectrum is taking it's going up and down, and it's going to here. Now, I'm looking towards this thing. I'm squishing around this radio wave. It can be a sound wave of it, but I am looking around this place right now. And this is taking measurements of me. This is to say something distances, but it's a perceptive module. A perceptive model of perception. So you can work with a system of non-reality. So system of so basically, this wavelet that's propagating in front of me is literally, I'm not doing it. Free way. So if I walk towards it, I can take a measurement of when I'm looking or not. So basically, it allows you to detect when someone is moving. It's a movement detector. But what's the latitude of longitude? So basically, it depends on where it propagates. So the way in front, say the more steps I take forward, there's a radio system there. It's a radio wave, and the most steps you take forward, it will be red.
Jesus.
Red. The more red I take, so red is the red shift person. So it works on red shift. So if I'm moving away or still, the system is static. So red shift. So it's taking a measurement of hue that is red. So so if I'm if I'm looking if I'm so again red, if I'm looking for something, it's red. It's in the focus of I'm casting a blue. A blue. It's whipping and squeezing against the wave. I'm squeezing against. I'm making the wave oscillate more. And the more it oscillates, the more blue hue I become. The more blue I get, red, green, blue. If I red, blue, yellow. So if I am moving away from it, the system is telling me go. So basically, I'm looking the other way. So the vector magnet I'm double, the vector and double, the vector and double. So I've doubled the vector of my calculation. But these are called auxiliary vectors. So I call them auxiliary vectors. So if I have a vector of 2, 1, 2, 1, and it's a column vector. It's a column vector, and you have 2, 1. You have 1, 2, 1 to column. So in the column vector will mean that I'm jumping up and down, basically. I'm jumping forward. So it allows you to see, think about what be jumping forward. System. So so I'm jumping forward. If I have a measure, so this is red. If I have red, so basically it's really goes from red shift. So it was so you get 2 to 1 mapping. So the 2 to 1 mapping means like it checks what I'm moving so something is coming closer to it or not. But to give us a shape of that thing as it moves closer, as more radio waves are sent to the system via the sensory system of the device. So that's how it works basically. It basically measures you based on the kind of orientation of latitude and longitude and altitude. But it's gonna be half a half. You're gonna have half a system, half a lockup, half a. It's gonna object because what's the detect what's wrong is that it's not a preset vector. It's a vector that's in memory, that's being calculated in real time. Force so that's really moving. Basically, it stores itself. So basically, you can have 2I plus 4J as a raw vector. 2 units of system. You're gonna have about 360. You're gonna have 2I plus 4J equals to 2I plus 4J, which is a raw vector of a measurement of something that's there, but not equal to anything. More than equal to. More than equal to, which is bigger, more than equal to 8I minus 12J. So basically, you can quantify a ratio of imaginary units, but basically because you go latitude longitude, basically you get a full shape of something, of signal. So it doesn't say via tap out sequence. Thank you. Watch this video. Video. I'll upload it to my YouTube. Thank you for watching, guys.